No, 70. 7, 8 times 3 is 4. 10 times 72. 2 times 20. So, no, they wouldn't.
They would not. Now, here's what I noticed, and this is one of many tools in your toolbox here. If you multiply 18 by 4, you get to 72. So 10 times 4, does that equal 38? So what I'm suggesting here is that in this problem, it might have made more sense to go to the larger fraction to say like, no, they are not equivalent. Like it's not always that you reduce. That's just one strategy of many.
Okay.
Okay. So let's look at a couple more here. 3.
3 plus.
So let
No.
me try to tell you what I see. Let's reduce this one to 9 over 14. You see how I did that?
Mhm.
And then can you go from 14 to 42?
Yes.
Yes. By multiplying by 3,
You could
what
also
is
just multiply
9?
20 by 2.
So these do work.
Mhm.
And that's why we go back to like, you may find that if you just always cross multiply, that will tell you like that always works. That's the hammer in your toolbox. If you're not sure what I mean by that, the hammer like works for everything, but it's not always the best tool for the job.
Mhm.
So this one I'll leave up to you to decide.
Okay. Uh, so 15. Um, 6 times 3 is 18. Yes, it would work. Right, equivalent ratio.
Good job on that. Your strategy on the next grouping of problems here is to either go bigger or smaller.
Mm,
Okay. So for example, here, like you could just double the numbers,
That's what I did for that one.
but if they can be reduced, like the second one can be reduced by 3, you might go smaller. Now, maybe
Mhm.
that's not always obvious or whatnot,
Yeah.
but that's up to you. You can always go bigger.
Okay.
And it's kind of up to you to.
Hmm. So, uh,
Any questions on that?
no.
Number 9 will require a little bit more explanation, I think.
Okay. Yeah. Like I
Four
have it before.
pencils to 10 papers. So the given's gonna go here, 4 to 10. And you could, for example, write a proportion for all the rest of these. Like let's just say you were trying to find this number here. You could write a proportion like this: 2 divided by x equals 4 divided by 10. Were you doing anything like that in class?
So what we were doing, um,
This is not the only way, by the way.
yeah, like we were trying to for like what we were doing, like complete table for grandma's lemon water. So I have the notes right here, and we like, what could you do for four? You could divide by two, but yeah, so it's sort of like this one. So this one doesn't have it, but last one we had like
Well,
complete.
this one you're trying to figure out 4 times what number gets you to 10. That's the like there's a multiplier
Mm, times two.
more than that. When you divide by 4 here, k becomes 10 over
Mm,
4, which is 5 over 2, which is 2.5 if you prefer that.
hmm.
So basically to go from the top row, the bottom row, you multiply by 2.5.
So 10 times 2.5.
Right, that gets you that one there. The 2 times 2.5.
The five.
Okay. So do the 28 times 2.5.
Mm, so 15, so that would become 56. 61.
Try again.
Wait, 28 times 2.5.
Yes.
Mm, mm, 70.
70 is correct. Okay. Now the question is, well, how do you go backwards? So if you multiply to go forwards, you must divide to go backwards.
So 30 divided by 2.5.
Yes.
Uh, 2.5, so 12.
It was 12. Good. Okay. Let's try number 10. Same
Mm-hmm.
idea here. So number 10, you've got to figure out how to go from 9 to 6, or you can go from 6 to 9. Like it's kind of depends on what you want to do. You'll end up having to go both directions in this one. But to go from 9 to 6, it's 9 times k equals 6. You divide by 9 and
6
you find
divided
that,
by 3.
yeah, you find that it's 2/3. So
Mm-hmm.
so you're going to take your top numbers and multiply it by 2/3. Now you already have the first one. Okay,
Mm-hmm.
that's there. Now you got to take 30 and multiply it by 2/3.
Okay. So 30 times 2 thirds. Can I grab my notes really fast? So.
Yeah, of course. Of course.
All right. So, okay. So, what I just so. So 20.
That's 20. Okay, now to go the other direction, here, you would divide by 2/3, which is a little weird.
Mm.
So remember, you change that to multiplication by the reciprocal.
Mm-hmm.
So you're going to take each of these bottom numbers and multiply by 3/2.
So 2 times 3/2.
Yeah, that'd be the first one.
3.
Okay.
8 times 3/2. 10.
Try again.
Mm,
You want to multiply by the top number and then divide by
12.
the 2,
Yeah.
you know.
Yeah. 12.
Good.
$75.
Very good. All right, you got them all.
Okay.
Okay. The number 11. All right, last year in Kenny's school, the ratio of students to teachers was 22 to 1. Write an equivalent ratio to show how many students and teachers there could have been at Carrie's schools. This is kind of like 5, 6, 7, and 8. You probably you have to go bigger in this problem, but they're real people.
So you could do, I guess,
I mean, I wouldn't overthink it,
2.
like
So
like
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 2 to 6
double,
or 2 to
multiply by
44.
10. Yeah, I mean 44 students to 2 teachers, that would be okay.
So okay. So how do you write that as like? Is it usually like 42 and then over 2 for like?
It is
Let's
44
say.
colon 2. Did you guys not use ratios in the classroom?
Well, she said that she prefers us. She she prefers us to do the other way, but the colon's fine.
Um, the you can write it however your teacher wants.
Mm-hmm. Okay. Okay. So number 12. What did you call it? What is the ratio of salamander? 5 to 8.
Is that okay? I mean, is that clear?
Yeah, it's fine.
All right. Um,
So
so
five.
so there's a little bit more here though to this. Like you're not getting the full picture. There is ratios and fractions are not all the same, but the teacher maybe is holding back on that. Um, Salamanders to frogs, um, in Cypress Pond.
So 8 to 5.
Yeah.
Okay.
Uh,
The ratio of salamander is the same. Um. Next one.
yeah. Where is the ratio the same? Bits?
Mill pond.
Well, what they're saying is like Mill Pond is 15 to 10. Is there another one? And these reduce, by the way. Like, see how this reduces to 3 to 2 if you divide them both by
Yeah,
5.
that's clear pond. Okay.
And then that's yeah, like you said, that's also clear pond. So that's the answer they're looking for.
So mill pond and clear pond.
Yes. The idea is that like whatever the ratio is, you can reduce them just like you can reduce fractions.
Okay. Okay.
Okay. Do you want to try the next one?
The ratio of cats to dogs in the shelter is 15 to 12. The shelter finds home to the same number of cats as dogs in one day. The ratio is the same. Explain. So no, would right?
Uh, well, so one of the ways you could do it is to like think of an example. Um,
Mm, So like 15 to
like so
12.
like yeah, like subtract 3 from both.
But that would
Is
still
that
be 11 to, or sorry, it would be 9 to 12. No, subtract 3 or 2. No, yeah, 3. 9 to 9. But it wouldn't be the same, would it?
well, so this is where you got to reduce the fractions. Like uh the
Divide by
top one here,
3.
if you divide them by 3, you get 5 to 4. If you divide these by 3, you get 4 to 3. Are those the
So
same?
no.
They're not. So you were right, but sometimes you got to like you want to show it in a way where it's meaningful.
Three.
All right, so on to the mixed review.
Okay.
All right. Costco sells a box of 25 bags of chips for $16.25. What is the unit rate? So the unit rate is always dollars per unit. So you put the dollars or the dollar amount on top and the units on the bottom, which is 25. So you do have to divide here. So give that a try, please.
Okay, so 'em. 65 cents to one bag.
Yep. Or $0.65 per bag. Good. All right, let's try, have you tried 2 and 3 now? These are just,
Mm. So, crap. Oh, negative 1.6.
okay, good. All right, the next one.
Mm.
They're both negative, so the answer is
Negative seven
negative.
over 7.1.
Yeah, there you go, good. Okay,
Right, each fraction is decimal.
job on that. All right, write each fraction as a decimal. So, start with A. You got to do the whole, outside the house, inside the house thing. B is a special case.
Oh, 0.4. 0.3 repeating.
It's just 0.4, not 0.4 repeating. B is a repeating one.
0.3, 0.3 repeating and
Yeah.
0.
Okay. Yeah. Good. How about for C?
0.25.
Try again. You've gotta just work it out this way.
1.
Like you can't jump to conclusion.
0.04.
But for B,
0.125.
good. Now for the last one here, the decimal is 3 point something, and you just figure out what the 7/10 is as a decimal.
3.7 or sorry.
Yep, you got it.
Oh,
3.7. Okay, so the number 5 is asking you to determine the slope of the line, which is like the rise over the run. Have you guys talked about that at all in class?
not really, no.
Okay, so there's this like rise part and then this run part. Um, not really sure how you guys are doing it, but um, it's this 80 centimeters. That's the rise part over 4 minutes. That's what's called the run part. So you have to find kind of a nice point on the graph there, like that, to
Mm-hmm.
use for this.
So 5. Right.
Let's try that again.
Um, 80 divided by 4.
Yeah.
Wait. 20.
20 centimeters per minute. Don't forget your units. Okay, good job on that. Let's go to number 6. We were doing a bunch of these for your review for your test.
Solve for x would divide, but 4.5 x divide multiple. They never do that. 4. X equals negative 25/2.
Okay. And you're in the mood of doing a decimal, minus 12.5.
Mm-hmm.
Okay. So 7 was a problem that you talked about for your
All
test. Hopefully that went okay on your test. Um,
right.
we talked about
So
this, that it's really
yeah,
8 times 10 to the minus 2 inside parentheses. So it's really 8 cubed times 10 to the minus 6, which means that you move the decimal place 6 times left. 1, 2, 3, 4, 5, 6.
so 0.00052.
Yeah.
Oh, 1, 2.
And you actually see this on like dental admission tests, stuff like this. That's not really difficult, but you have to be paying attention or you can easily get the wrong answer.
Mm-hmm. Simplify. So this one's not. It's just like,
So this looks kind of new for us.
well,
Um,
they like isolate. Like, it's sort of like you take the x squared and the 4x, or
yeah,
you
these are
just
considered like terms.
yeah. So like combining like terms, I guess.
Yes, exactly. You might have to, for a while, put like 1 in front of x squared, or if you just have a single x,
Yeah. So 5 squared,
x squared.
five
Then you
x
got
squared minus
minus 3x minus 1x.
x squared minus, so 3x plus 1 minus 1, 2x.
It's minus 3x minus 1x. They're both negative.
So you would, oh, so -4.
Yeah. We're gonna do another one like this here in a moment.
So 5x squared minus 4x plus 2. So then equal what? So from square, you get 25x.
No. You're just adding and subtracting. There's no multiplication.
Well, couldn't you just change the 5x squared to 25x and then
There is
do
no. It's just 5x squared. 5 times x
okay.
squared.
Okay.
Yeah. Uh,
So
let's do something simpler because that
1x,
plus two. Plus two.
1x. Oh, 1x squared. So 3x squared.
No, you cannot combine these. These are not like terms. They don't have the same power, exponent power.
So, but when you
No, this is it. This is
okay,
it.
like that. Okay.
Yeah. So like, let me give you a simpler example. 4 plus 3x plus 5.
Mm-hmm.
The
The 4
4
plus
and the
5 you can
5 are
remove. So it would be 9.
9 plus 3x, and you cannot combine those.
Mm-hmm.
So now about like 2x squared plus 1 minus 4x squared. What can you combine? Well, you combine the 2x squared with the minus
Negative
4x squared.
2x squared plus 1.
Very good.
Okay.
Okay, so now if we increase the complexity just a little bit here, let's go 3x minus 4 minus 5x plus 1. Gives you
Negative 2. Okay, so then 2x. So negative 2x plus 3. Negative 3
minus 3, yeah.
minus
And then
3.
last thing here is let's say you have more than one x, like you have like 1x squared minus 2x plus 3x squared minus 4x. They
2x
have
and
to
the
have this.
4x and the 1x and the 2x. Yeah.
Yeah, they can only combine if they got the same power. So that's 4x squared minus 6x.
Yeah. So
Okay, we'll come back to that maybe here. Let's talk about how to do number 9.
order from least to greatest, you can change them to fractions or decimals. I'm guessing the best thing to do here is just changing them all into fractions or all in decimals.
If one or the other. I like decimals because this one's 0.25. That's not too bad. And then this one, you got to do the 9 into the 2. You only have to go out far enough, though, to be able to match it up to the ones that are there.
Mm-hmm. None of them 20. Twice. 15. 2. We're gonna 0. So 20. So 2 repeating.
Okay, so but like I said, you only have to go out far enough to get to where you can compare.
0.22.
Yeah.
Okay, so then we do. It's from least to greatest. The least is 1 or the 17.17, then 0.22.
You have to go back to the original, though.
Yeah, I know. I'm just like
Yeah,
that.
it's okay. Yeah, it's an intermediate step. That's fine.
Yeah. So, okay. 10, -5. Okay.
So I'm gonna put the words here. What to do? The first one says to negate 1 to the power of 5.
So
The
5,
second
but
one says -1 times itself 5 times.
so
Now they
that's
might equal the
negative
same
5,
thing,
or sorry, that'd be -1,
okay?
and that'll be 1. Or,
So did you multiply it out or did you just
well,
kind of
negative
feel?
1, -1 is -1, right?
Yeah, so they're both actually -1.
Okay.
Okay, so we got some time left here. Let me just throw out some problems for you to try here. How about 4/3 times negative, I'm sorry, 4/3 times x equals -16.
Mm-hmm.
Let me make that a little bit more. Go ahead and solve for x, please.
Um, uh, -12. X equals
It's
-12.
negative, is -12, good. All right, if 7 cubed equals 343, then 0.07 cubed equals what?
0.00, so 0.0004, or sorry, 343.
All right, good, good. Okay.
And I think I'm gonna end a little bit early because I do have a headache, but
Oh, sure. Yeah, absolutely. As long as we get through everything that you want to get through, we can
thank you.
absolutely stop there. So, okay, like I said, if you need a lesson next week, please let mom or dad know.